Hi, this is Mrs. Basin, and today we're going to talk about naming and writing formulas for molecular or covalent compounds. So first we're going to talk about how to name them. So what we have to remember before we start is how to identify something as a covalent compound. So a covalent or a molecular compound, those two words can be used interchangeably, contains only nonmetals. And we are going to focus on naming binary covalent compounds. So covalent compounds that only have two elements. So before you apply these rules, you have to make sure that you are dealing with a covalent compound. When the order is written for a covalent compound, the least electronegative element is always written first. So that's how they decide which of the two nonmetals comes first and which one comes second. So when we name a covalent compound, the first element is named first and the second element is named second. So whatever's written first comes first in the name, whatever's written second comes second in the name. To name the first element, we just use the name of the element. And then if there's more than one, we use a prefix to denote how many of that element are present. The second element is named by using the name of the element with the IDE ending, just like we did before. And then now we're going to add a prefix to denote how many of the element are present. So the second element always gets a prefix. So first element, element name, prefix if there's more than one. The second element, drop the ending, add the IDE, and then use a prefix to tell how many of the element are present. So these are the prefixes we're talking about. These might look similar to things that maybe you've used in math before. So 1 is mono, 2 is di, 3 is tri, tetra, penta, hexa, hepta, oxa, nona, and deca. So you'll want to make sure that you have those memorized before we get to a quiz or a test. Okay, so let's try some examples. So name of the first, prefix and IDE on the second, prefix for the first element if there's more than one. So there's only one of the first, so this would just be boron. 3 is tri. Drop the ending, add IDE. So boron trifluoride. Next one, H2O. We know this is water, but we're going to write the technical name. 2, so more than one of the first element, so we need a prefix. Dihydrogen. 1 of the second, monoxide. So second element always gets a prefix. First element gets a prefix if there's more than one. Next one, 2 nitrogen, so dinitrogen. 5 oxygen, pentoxide. Next one of each, carbon, monoxide. And the last one, carbon dioxide. Okay, so name of the first, IDE on the second, prefixes always on the second element, prefixes on the first element if there's more than one. So pause the video, try these out, and come back and check. So CCl4, carbon, tetrachloride, NO2, nitrogen dioxide, IF5, iodine, 5 we haven't used yet, penta, fluoride, 2 iodine, so diiodine, 7 is another one we haven't used before, heptoxide, and then last one, this is another one that has a common name. This one is called ammonia, but we're going to call it nitrogen trihydride. So name of the first, IDE on the second, prefix always on the second element, prefix on the first element if there's more than one. Okay, now we're going to look at how to write the formulas for molecular covalent compounds, and this is probably the easiest of all of them. So when you write the formulas, all you have to do is decode the prefixes. So there's no crisscrossing, there's also no reducing, so we never reduce the subscripts for this because when you look at the formula of a covalent compound, it's the actual formula of it. It's not a formula unit like an ionic compound is. So for covalent, there's no reducing. So no crisscrossing, no reducing. All we have to do is decode the prefix. Dihydrogen means 2 hydrogens, monoxide, 1 O, so H2O. So again, no crisscrossing, no reducing. The prefix tells us how many of that element are present in the formula. Carbon tetrachloride, so 1 carbon if there's no prefix. Tetra is 4 chlorines. Last one, dinitrogen, 2 N's, dioxide, 2 O's, and we leave it as N2O2 because, like I said, there's no reducing. So pause the video, practice these, come back and check. Dicarbon dihydride, so 2 carbons, 2 hydrogens, again, no reducing. Nitrogen trihydride, so 1 N, 3 H's, and then carbon dioxide, 1 carbon, 2 oxygens. Okay, so the big thing to remember here is these rules only apply to covalent compounds. So you can't go back and start sticking prefixes on all the ionic compounds that we already learned how to do. Those rules are specific to ionic. These rules that we just talked about with the prefixes, those are specific to covalent compounds. So that's why it's so important that when these are all mixed together, first thing you have to do is identify what kind of a compound is and then apply the rules for that particular type of compound.